So what is the sequence? So it's a list. It's a list of ordered numbers. Okay. Number two, what are the three different types of sequences? The first one we call it arithmetic. Okay, that means there's a common difference. Okay, we'll call it D. So that means you add or subtract the same number. So let me give you an example. Joey? Aaron? You're supposed to do that before. Okay. Jordan, pick a number. 5, so we'll start at 5. Okay, Karina, pick another number. 7. We'll add by 7. Okay, so the next number will be 12. And 12 plus 7 will be 19. And then 26, dot, dot, dot. Okay, are we good? Okay, I'll give you another example. You can also subtract the same number. Let's go, Cindy, pick a number. 247. 247, all right. And Angelica, pick another number. 13. Oh, you guys want to subtract by 13? Okay. So we're going to subtract 13, so that'd be 234. 234 subtract 13 is 221. And you guys get the point. Okay. So far we good? Now we're going to write the formula for these sequences. We'll start with the first one. So we're going to write Tn. Ends in the subscript. It's kind of like the exponent, but on the lower side. Okay. What was the common difference that to get to each number? 7. So we're going to write plus 7n and leave a space to write where you started at. Okay. We're not going to write the first term. We're going to write the term before the first term. Okay. So how do you get to the term before 5? Minus 7, which is 2. Negative 2. Okay, and that's the formula. What that means is, if I want the first term, I'm going to plug in 1. What's 7 times 1? 7 plus negative 2, which is 5. Okay? If I want the second term, I plug in 2. 7 times 2 is 14. 14 plus negative 2 is 12. So this is the formula for the sequence here. Say I wanted the fourth term. What number do you plug in? 4. 7 times 4 is 28. 28 plus negative 2 is 26. Okay? Are we good with that? Alright, so let's practice one more. Tn right here, the one that we wrote. What was the common difference here? 13. Add or subtract? Subtract. So we're going to write minus 13n because we subtracted. So that means the sequence is getting smaller. Now we don't want the first term, we want the term before. Okay, so 260 because I added 13 to get to the term before. Okay. So far we're good? 260 because 247 plus 13 is 260. Okay. The second sequence is geometric. And this is from geometry. You compare shapes, so we call it a common ratio. Okay, and we'll call that R. So instead of adding or subtracting, you're going to multiply or divide by the same number. Alright, so let's think of easy examples. Don't try to make it so complicated, please. Just pick a small number. Okay. Heaven, pick a number that we want to start at. 4, so we're going to start at 4. Pick a really small number that we want to multiply by. Okay, Adrian? 2. So 4 times 2? 8. 8 times 2? 16. And you guys get the point. Okay? You can also go backwards. You can divide by the same number. This example is harder to come up with, so I'll think of a number. 270, and we're going to divide by 3. Okay, so what's 270 divided by 3? 90. What's 90 divided by 3? 30. 30 divided by 3? 10 divided by 3? 10 divided by 3. Okay, 10 over 3 divided by 3? 10 over 9. 10 over 9 divided by 3?
10 over 27.
Thank you. Okay, you guys get the point. Alright? Okay, geometric is you write the formula a little different. This one's actually a little easier. Okay, where do we start at? What number did we start at? 4, so 4. And what's the pattern? Multiply by 2. And in the exponent, you're going to just go ahead and write n minus 1. Are we good with that? Alright, second example for geometric. Let's practice writing the formula. What's the first term we started at? 270. What was the pattern? Divide by 3. What's another way to say that? 1/3. And then in the exponent, you write n minus 1. Okay? What does n represent? Whichever term you're talking about. Say I want the first term. I'll plug in one number here. 1. 1 minus 1 is 0. 1/3 is 0 is 1. 1 times 270 is 270. Okay, say I wanted the second term. Plug in 2. 2 minus 1 is 1. A third to the 1 is a third. A third of 270 is 90. Okay, are we good? And the last sequence is neither. So that means you don't add or subtract, you don't multiply or divide by the same number. These sequences are a little harder to recognize, so I'll give you the easier ones. We'll go 1, 4, 9, 16, dot, dot, dot. Okay, some of you guys recognize it really quick. Okay, if you notice, these are squares. So the next number is 25. The next number after 25 is 36. Okay, so let's go ahead and write this formula. T of n equals n squared. Okay, I'll give you another one just in case. We'll go 1. We'll go 8, 27, 64, dot, dot, dot. Okay? And if you recognize it, it's cubes. Okay? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27.
So it doesn't matter as long as they're in relation of the exponents?
There's other sequences that are a little harder than this. I'm just giving you the easier ones.
Okay,
Okay, are we good? So that means you didn't add or subtract by the same number, you didn't multiply or divide by the same number. Okay? Okay, example. Determine whether the sequence is arithmetic. Arithmetic means you're adding or subtracting the same number. Geometric means you're multiplying or dividing, and neither means none of the above, okay? So 7, 13, 19, dot, dot, dot. Okay, so try to find a pattern. Try to add the same number. 7 plus what gives you 13? 6. So is 13 plus 6 19? Okay, so we found a common pattern, plus 6. So this is called arithmetic. Okay, second example. 3, 6, 12, dot, dot, dot. Okay, so first I would try adding. 3 plus 3 is 6. 6 plus 3 is 9. That's not 9. So try something else. I would try multiplying. 3 times 2 is 6. 6 times 2 is 12. So it's the same pattern, so we say times 2. So this is called geometric. Alright, third example. Try adding. I don't know how to add fractions, so forget that. Try multiplying. 1 times 4 is 4. 4 times 4 is 16. Is this 16? No, okay. So it's neither. Okay, are we good?
Mm-hmm.